Hello students, till now we have studied the definition of log and today we are going to learn the laws of logarithm. Before we start with the laws of logarithm, we will first review what was the meaning of log. Let's take this example. Log to the base 3 of 9 is equal to 2. So we have learnt that to what power this 3 should be raised in order to get this 9. It means if the growth rate is 3 times, then how many times the growth should happen in order to get my final result 9. That's how we can relate this function is. So hence we know that 3 square is equal to 9. Let's take another example. If I say solve log to the base 327. What is the answer? So over here, the growth rate is 3, the final result is 27 and we have to think how long this 3 should go on multiplying in order to get 27. So we know that 3 into 3 into 3 gives me 27. Hence, over here the answer is 3. That is 3 is raised to power 3 in order to get 27. In this way, this log and exponents, they are related to each other. Let's solve one more log example. Suppose if I take log 5 is equal to question mark. So now I will think that 5 should be raised to what power in order to get 5. It means 5 is the growth rate and it should be multiplied how many times to get 5. So 5 is not going anywhere, it is the result is 5 only. It means I should raise 5 to not only 1 because it is 100%. So this growth rate is 5. When it stays same, then the final result is 5. Therefore, we get the relation 5 raised to 1 is equal to 5. If we have to solve log 625 is equal to, so here again 5 should be multiplied how many times in order to get 625. So we know that 5 should be multiplied 5 into 5 into 5 into 5. That is 25 into 25, we get 625. So 5 should be raised to the power 4 in order to get my final result 625. So the growth rate is 5, the final result is 625 and the growth is happening 4 times so that we get the final result as 625. Hence our answer is 4. Now what if I give you, let's say, two equations, log 5 and log 125. Over here, I know this, that the growth rate is 5, final result is 5, means I am not going anywhere. It means it is 100%, hence my answer is 1. Because 5 to the power 1, I haven't gone in future or I haven't gone backward. It's the growth rate 5 is same because this number has not grown. So it remains 5 raised to 1, hence the result comes 5. So what if I give you log 2. So here also it will be 2 remains 2. The growth rate was double, but the object remains same, that is 2, and hence it has not gone anywhere. So 2 has raised to what power in order to get final result 2? It is 1. Hence we are going to write here 1. So from here, what are we concluding? We are saying that when the number is remaining same as the original value, then the answer is 1. So if any number, when it starts with certain growth rate and remains with the same value, the in that case it is same, the result is 100% and hence it is 1. So we can write down the first law which we see in general over here, that log to the base a is equal to 1. So this is the first law of logarithm. Now let's say this is equation 1 and this is equation 2. So my equation 1 is, let me write it properly. So our first law which we have got, we'll make a list over here, that is laws of logarithm. The first law is log to the base a is 1. Now I know that this is my equation 1. Now let's think of the second equation. Over here, log to the base 5 of 125. Now we know the answer is, it is 3, because 5 has multiplied 3 times to give me the result 125. Therefore, the answer for the second equation is 3. Now what if I add these two equations and log to the base 5 plus log to the base 5 125. Now how can I relate equation 1 and 2 in terms of, let's say, this equation? So if I have to relate these two equations with this, will I be able to find out some relation between them? Now look here, this is 5 raised to 1, which was 5, and 5 raised to 3, which is 125. So here it is 1 and over it is 3. If I look over here, this number, which is a result, is equal to the product of this 5 and 125. So if I have to find out the relation between equation 1, 2 and equation 3, then I see that 5 into 125 gives me 625. So I can write down over here that log to the base 5 into 125. Now if you look carefully, this is 1 plus 3 is equal to 4. So 5 raised to, so we can see the relation that when logs are multiplied, they get added. Because if you look at their values, 1 plus 3 is equal to 4. So we come across a law where we can say that if logs are having same base and if they are multiplied, then we can add them. So this is how we get the first law of, this is how we get the second law. This is the first law. Now the second law, actually there is no such thing as first, second and all, but this was the simplest thing to find out. That's why it was log to the base 5 of 5 is equal to 1. So hence we got it easily. But over here, when we try to add these two equations, we end up getting this relation between them, which satisfy my this condition, 1 plus 3 equal to 4. And therefore, I can say that log to the base 5, a into b, that is 5 into 125, gives me log to the base 5 plus log to the base 5, 125. And hence, in general, I can write down that log, the base should be same. So I can say log to the base here, I'll write down base as a, b into c is equal to log a b plus log a c. Now it's very important that they should have a same base. Then only this law is applicable. So if you observe here, in the reverse order, we know that we have studied in the indices that a to the power b into it's a to the power b into a to the power c is equal to a to the power b plus c. So can you find out the relation that how exponents are in a reverse order related with the log? So if the base is same, then we add the power. That's what we have learnt in the exponents. So a is the a, the base is same, b into c, which is b plus c. The same thing we are doing here. If you look at this equations here, base is same, 5, 5 and 5 to the power 1 into 5 to the power 3, which is giving us 5 to the power 1 into 5 to the power 3 gives me 5 to the power 3 plus 1, which is 5 to the power 4. So this is our law for multiplication of log. Now let's look at the third law. So if this is true with respect to multiplication, then we can easily deduce that it will be true for division also. So let's do the division. So the log b divided by c, where base is a, I can write down this as log to the base ab of b minus log to the base a of c, because we know that a to the power b divided by a to the power c is equal to a to the power b minus c. So this was a law in our exponent. The same thing in the reverse order. If it is division, then it is a subtraction. So log to the base a of b minus log to the base a of c, that is our subtraction. So in case of division, we subtract the log. The rule, a should be common base. Now let's look at the next law. Okay, we take an example where we use this multiplication law for discovering one more law. Now let's say, if I say that if I give you two numbers, log a, b or b, it's not b, it's b plus log base a and again b. So over here I know that addition of the two logs of having same base, it means multiplication. So I can write down same thing as log to the base a b into b, which is equal to log to the base a b square. Over here log is added two times, so I can write down 2 log to the base a of b. Now let's check one more step, like one more example. Log, if I take over here base as 3, 2, again log to the base 3, 2, log to the base 3, 2. So I am adding this 3 times, but I know addition means it is multiplication. So I can write down this as log to the base 3, 2 into 2 into 2. So I get log to the base 3 2 cube, which is equal to 3 times of log to the base 3 2. So what do we observe here? This 3, which is index, it has become coefficient of the log. So whatever power we raise to the given log value, we can take it out as its coefficient. So this is one more law which we come across, that if log to the base a b n, then it is true that this n goes over here, which is n log to the base a of b. So this is another law. Now we will study one more property, that is already what we have seen, that log, let's say I give this example, log to 1. It means to what power this 2 should be raised in order to get this 1. So I know that 2 is is not going anywhere, and that's why the final result is 1. So it means 2 should be raised to no power, that is 0, and hence answer is 0. So we know that whenever our answer over here is 1, then the growth remains same, and hence this number is raised to nothing, that is 0, and therefore we write 0. So we can generalize this, that log to the base a 1 is equal to 0. This is another law which we get. Now the next derivation we'll see for change of base law. First let's write down the law. So the law says that if I have log a b, then I can write down this as 1 upon log b a, or I can change the base and make 2 logs out of this. So if I have this log to the base a of b, I can change the base, and I'm going to write base, let's say I'm going to write base c upon log base c of a. So let's derive derivation for this law. So let x is equal to log to the base c, log to the base a of b. Let x is equal to this, and I want to derive log to the base b, log to the base c of b divided by log to the base c of a. So to derive this, I am assuming x is equal to log to the base a of b. This is LHS of our result. Now from here, if let's write down how we write in exponent form. So how do we write this in exponent form? We write as a raised to x is equal to b. A raised to x is equal to b. Now further, if I want to reach from here to here, then I have to think that I want this value equal to this value. So how do I think about it? So I will say how long, or how this time, this is the answer for the exponent. Now I'm going to think as this value, let's see, is the growth rate. So the time taken for the C to reach this growth rate is equal to the time taken for same C to reach same value. So the resulting value is same. So I need to think in terms of my log definition, that let log to the base c of a raised to x is equal to log to the base c of b. It means the time taken to reach c to the value a raised to x is equal to time taken to c to reach value b. Now further, we can write down this x as coefficient by using the law which we have learnt here, that when it is raised to some power, we can write down that as coefficient. So that has become x log c a is equal to log c b. Further, let's find out value for this x. So I'm going to keep this x as a subject. That's going to become log to the base c of b divided by log to the base c of a. But what is my x? I have started with assumption x is equal to log to the base a of b. So I'm going to write down this for this x. Therefore, our result is log to the base a of b is equal to log to the base c of b divided by log to the base c of a. And this is what we wanted to derive. So this is how we found out the derivation for change of base. Now there is a small case here. What if over here, if this B and C both are equal? What if B and C both are equal? So in that case, this is if B is equal to C. Therefore, this is going to become log to the base AB is equal to log BB upon log to the base C of A gives me 1 upon log instead of C, I'm going to write here B, so that's B A. And this is how we get our result for change of base law in both the cases. So let's start with the practice examples of logarithm and using our laws which we have learned. So far we have studied all the laws and how to apply them. So we'll take stepwise. Like we'll start with a couple of really easy examples where you will get used to the application process, and the next we will start with the equations of log and we have to solve for the unknown value. So to begin with, let's revise through the laws first. So the first law which we saw was log to the base A of A is 1. Second, if log to the base A 1, then it is 0. So log of 1 is 0. Third, if base is same and it is multiplication, then we add them. So multiplication is addition and division is subtraction. So division is subtraction, that is log to the base A B minus log to the base A C. Change of base law, log BA can be written as log BC and log base is C A. If B is equal to C, then log to the base AB is equal to 1 upon log to the base BA. So far so good. So we will see now today practice examples which are based on our laws. First we'll run through the laws once again and then we'll start with the examples. To start with, the first law which we saw was log to the base A of A is 1. Second, log to the base A of 1 is equal to 0. If log to the base A, it is B into C, that's multiplication, is equal to the addition of two logs. So that is log to the base A, B plus log to the base A, C. If it is division, then we can express the log into subtraction. Next was change of base law. Here log to the base A, B can be written with the new base C, where we'll say log to the base C of B upon log to the base C of A. Earlier we have seen the derivation of this law. But what if B and C both are equal? So if B and C both are equal, then it becomes, this is become BB, and hence this becomes 1, and instead of C it becomes B. Hence we get the result log to the base A of B is equal to 1 upon log to the base B of A. Next was this power law. If any value of the log is raised to some power, then that can be written as coefficient. So this n goes as a coefficient, which is n log to the base a of b. Now how do we apply these laws? That we'll see with basic examples. So let's take first example, and example here is log to the base 218 of 18 minus 2 log to the base 2 3, and the question is solve. Now observe here, I can see this 2 is a coefficient. Using this law, this coefficient can be raised as a power of this, because n log to the base a of b is equal to log base a b to the power n. So I can write down this 2 as a power of 3 according to this law. So log to the base 2 18 minus log 2 3 square, and that further gives me log to the base 2 18 2 of 18 minus log base 2 of 9. Now again base is same and it is subtraction. So base is same, if it is subtraction then it is division. So the next step we can write down this as log base is 2 and it is division. So I write down 18 divided by 9, which is 9 2s are. So log to the base 2 of 2. And now I know that when it is log of same base and same value, I haven't gone anywhere, the growth hasn't happened, it means it is 100%. So the answer is 1. So over here, according to that rule which we have found out, it is 1. So my final answer for this equation is 1. Now let's see another example.